Bismillahirrahmanirrahim. Dear students, this is your third performance about given compound toluene. Same as before in your two performed lab activities. You have to perform preliminary examination, then identification of elements or any element, then detection of functional group, and last but not least, derivative preparation. I have given it's some wet and dry tests, state color order, ignition, dry tests, and you can conclude many things because order is paint thinner smell, so you can guess that it may be toluene. And aromaticity is again very important factor. Litmus test that it is neutral. Now you're seeing that things are supporting your guess that it may be toluene. Decolorization occurred. I have told you that methyl group on benzene is being oxidized by this oxidizing agent KMNO4. So you can easily conclude that it is toluene and it is oxidized into benzoic acid. You can write here an equation. You have to write toluene plus KMNO4, write on the arrow oxidation process, and benzoic acid is obtained. Uh, Original organic compound, sorry, plus sodium bicarbonate, no gas evolved because absence of carboxylic group on toluene. Soluble in hexane and ethanol because toluene is non-polar, hexane is non-polar, and organic compounds are mostly dissolved in ethanol or ether. So no chairing, it means sugar group is absent, carbohydrates are not present, and boiling point is also indicating that our guess at the start, paint thinner like smell, is supporting the presence of toluene. One thing more, when you see that KMNO4 is decolorized and paint thinner smell, and these other factors are supporting the presence of toluene, you should heat the compound with bromine water. So there are two possibilities that substitution may be inside the ring, on the ring, or it will methyl group, it is substituting methyl group. Then the same procedures, same protocol, that after preliminary test, element detection, preparation of Lazane's solution, place a piece of clean sodium metal about the size of a small little pea into a fusion tube. You have to be very careless while cutting your sodium metal. It is very hazardous. Sometimes it catches fire. Add a little of the compound, your organic compound, on. You should cover that small piece of sodium metal, and if the given compound is liquid, then it is better heat the metal before pouring organic compound. Afterwards, heat the tube gently, and so you are sure that the sodium metal is molten. When charring begins, you will hear the voice of charring. You have to carefully heat the bottom of the tube, and you will see it will burn like a coal, red, for about 3 minutes. And finally, you have to keep fusion tube on the flame, remove it, then sometimes it will bump the sodium metal, and your compound, they will be uh, heating in such a way that it is coming out of the fusion tube. So you have to be careful. Now when it is still hot, put this fusion tube in a clean dish already containing cold distilled boiled water, and cover it immediately with a clean wire gauze. Filter it and keep it in the test tube labeled as a Lazane's solution, or you can write sodium extract. Then I have already told you that for liquids it is better to first melt the sodium, then add the liquid drop by drop. These are some preliminary precautionary, sorry, not preliminary, precautionary steps. Then again, that this is um, toluene, and in toluene, there is no element like nitrogen, sulfur, sulfur, nitrogen simultaneously present, or halogens. All these elements are absent, and you will get no reaction or characteristic reaction of these elements. Then, as I told you during heat, bromine water, when you added bromine water, I told you there is possibility of two types of substitution: on the ring and substitution into the methyl group. So the halogenation of methyl benzene, substitution reactions, it is possible to get to quite different substitution reactions between methyl benzene and bromine depending on the conditions used. The bromine can substitute into the ring or into the methyl group. When possibility of substitution on the ring, this substitution occurs when aluminum bromide, or iron, is used and there is no light. These reactions occur at room temperature, and you are seeing that 2 chloro methyl benzene and 4 chloro methyl benzene are obtained, because methyl is orthopara director. Then substitution into the methyl group. If bromine reacts with boiling methyl benzene in the absence of a catalyst but in the presence of UV light, as uh, in this reaction is happening, uh, the product is methyl chloromethyl benzene. Now, how do you write your result? You will write the given your provided compound was found to be toluene, and then write down its characteristic features. You have seen that it was liquid, It was neutral. It was having characteristic thinner or benzene like smell. Its chemical formula C6H5CH3. Functional group, it is aromatic hydrocarbon. Melting point 110 degrees centigrade. It decolorized KMnO4 because it is easily oxidizable. It is converted into benzoic acid. It is oxidized. Toluene is oxidized into benzoic acid. And decolorization of bromine water is due to the chloromethyl benzene, as methyl outside the ring is substituted with chloro group. And in the presence of catalyst ammonium chloride, substitution on the ring occurs. Molecular formula C6H5CH3 or PHCH3 or C7H8. Its structure is ethyl. So I'm sure inshallah you have understood it nicely and you will be able to write it correctly. Some reactions you have to write down, simple reactions. So again I'm telling, if you have some ambiguity, confusion, some issue, you can ask fearlessly. Don't shy to ask anything. Assalamu alaikum wa rahmatullahi wa barakatuh.